Rajshahi, Higher Maths, 2017, Question 7. Musa Ibrahim saw that a hill subtends an angle of 7 minutes at a point 540 kilometers from the foot of a hill, and wrote an equation is x equals tan theta plus sec theta. In part A, find the height of the hill. Well, to solve this, since the angle is very small, we can assume the height of the hill is the length of the arc. So, using the formula, length of arc equals pi over 180 times r theta. The angle is 7 minutes. Each minute is 1/60th of a degree, so the angle theta is 7 over 60. So the height is equal to pi over 180 times the radius, 540 kilometers, times the angle, 7 over 60. Now the 180 cancels with the 540 to give 3. That 3 will also cancel with the 60. So we'll end up with 7 pi over 20 kilometers. If we take pi as 3.14, we get the height is 3.14 times 7 over 20, which works out to be 21.98 over 20, or 1.099 kilometers. So the height, rounded off to one decimal place, is 1.1 kilometers. Now in part B, we want to show from the equation that sine theta equals x squared minus 1 all over x squared plus 1. To do this, we want to prove if x equals tan theta plus sec theta, then sine theta is x squared minus 1 over x squared plus 1. Now, the right-hand side is x squared minus 1 over x squared plus 1, and if we substitute x is tan theta plus sec theta, we get this is equal to tan theta plus sec theta all squared minus 1 over tan theta plus sec theta all squared plus 1. Now, tan theta is sine theta over cos theta, and sec theta is 1 over cos theta. So substituting that, we get the top is equal to sine theta over cos theta plus 1 over cos theta all squared minus 1, and the bottom is the same except plus 1. If we multiply top and bottom by cos squared theta, on the top we get sine theta plus 1 all squared minus cos squared theta, and on the bottom sine theta plus 1 all squared plus cos squared theta. What we have on the top is sine theta plus 1 all squared can be written as sine squared theta plus 2 sine theta plus 1, and exactly the same on the bottom. Now we can rearrange, and we get on the top sine squared theta plus 2 sine theta plus 1 minus cos squared theta, and on the bottom we get sine squared theta plus cos squared theta plus 2 sine theta plus 1. Now we can simplify those. The 1 minus cos squared theta can be written as sine squared theta, and on the bottom the sine squared theta plus cos squared theta can be written as 1. So this leaves us with 2 sine squared theta plus 2 sine theta all over 2 sine theta plus 2. Now the top has a common factor sine theta, so it can be written sine theta into 2 sine theta plus 2 over 2 sine theta plus 2, as long as sine theta is not equal to minus 1, because otherwise we'd have a denominator of 0. So the 2 sine theta plus 2 cancels, leaving sine theta, which is what we were required to prove. Now in part C, from the equation, if x is 1, find the value of theta, where theta lies between 0 degrees and 90 degrees. To solve this, we have x equals tan theta plus sec theta, but we have shown that sine theta is equal to x squared minus 1 all over x squared plus 1. So if we let x equal 1, we get sine theta is 1 squared minus 1 over 1 squared plus 1, which is 0. So sine theta is 0, which means the angle theta is 0 degrees.